Hello, 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 Mr. Klinkerman. We're learning today about how you do what's called classifying polygons. Alright, now obviously we're not going to spend the entire year just talking about angles and line segments. There are some other things that we're going to have to get into, and we are studying shapes, and so we're going to start getting into shapes and how you name certain types of shapes and so forth today. We're going to do this in two videos, and the first one will be very quick, the second one a little bit longer. I'm going to tell you that the information that's in these videos is very simple, but there is a lot of it. Okay, so what it's going to require of you is to do some studying. You'll understand it. You just got to remember it all, so you're going to have to do some studying of the notes that you're going to take and so forth. Alright, now in the first video that we're going to watch from this section, we're going to accomplish goal 1 right here, which is going to be where you will be able to classify a polygon as convex or concave. Now kind of along with that, we're going to talk about what does it mean for a figure to be a polygon. Alright, and then we'll talk about how you classify it as concave or convex. And then in the video afterwards that you'll see, well, it'll take a little bit longer, you're going to learn some other ways of classifying polygons. You'll be able to classify a polygon based upon its number of sides. For instance, you probably know what a 3-sided polygon is and a 4-sided polygon already. We're going to learn some names for 5-sided, 10-sided, 12-sided polygons and so forth. And you will also be able to determine whether a polynomial is equilateral, equiangular, or regular. Alright, well let's get right into this video lesson then. And the first thing that we need to do is answer this simple question: what is a polygon? Now I've got 4 shapes on the screen, and each of them is a shape that you might be able to recognize or describe. Maybe this third one that's right over here you can't really describe, or sorry, recognize. That's just some kind of random thing. Nevertheless, these are 4 shapes. And if I wanted to look at a shape and know if it's a polygon or not, what are the rules that I follow in order to determine yes it is or no it's not a polygon? Well, one thing that I'm going to share with you right now is that whenever we're talking about polygons, we are talking about 2-dimensional shapes. And all of these are 2-dimensional shapes, and so they all have potential to be polygons. Okay, but a pyramid, a sphere, a cone, those types of things cannot be polygons. Alright, now you're going to have to pay a lot of attention to the rules. There are some details, very simple ones, but there are details nonetheless. The first rule for determining whether a 2-dimensional figure is a polygon is this: it has to be formed by 3 or more sides, and those sides have to be line segments. Now let's give an example here. One type of polygon that you guys already know is a triangle, and it turns out a triangle is the polygon with the least number of sides that you can draw. Because if you only draw 2 line segments, the best you can do is make an angle. But as soon as you add a 3rd line segment, it's possible to draw a polygon. Now notice each side here is a line segment, and those are sides. And of course you can have polygons with many various numbers of sides. There's a 6-sided polygon right there. Okay. Now the big thing that I need to communicate to you with that is that the sides do have to be line segments. Now they could be lines or rays, but really they're going to be line segments. But the point here is that they cannot be curved. If you ever have any kind of 2-dimensional figure with a curved shape, alright, such as this, that's not a polygon. Because one of its sides, right there, is not a segment. And it's required that all the sides are segments. Okay, so a polygon has to be formed by line segments. Secondly, and this one seems more complicated, but I can show you an example of what it's referring to. Each side of a polygon intersects exactly 2 other sides of the polygon, so that no 2 sides with a common endpoint are collinear. Each side of a polygon intersects exactly 2 other sides of the polygon, so that no 2 sides with a common endpoint are collinear. Now the easiest way for me to explain that second rule is to show you an example of a two-dimensional figure that would not fit that description. And here's a good example of that. Often called the bow tie figure, but it's really just a couple of triangles put together. But if you consider the figure as a whole, all right, part of what that whole thing was saying is that each side intersects exactly two other sides. Now, you can see that the side that I just drew right there, it touches, or that's the side, and it actually touches three more sides, which kind of breaks the rule that we were talking about. All right, it intersects that side, intersects that side, intersects that side, intersects that side. That was four sides, wasn't three. Okay. In a polygon, such as a triangle or a square or something like that that you're used to seeing, that doesn't happen. Let me draw a rhombus right there. Okay. This in a rhombus, if I look at any one side, it intersects exactly two other sides. All right, that side that I already highlighted intersects this side, intersects this side. There you go. All right, in a polygon, any one side can only intersect two other sides. And none of the sides can be collinear with one another. And if you look at the original polygon, that's another reason why it's not a polygon, the original figure. I didn't say the original polygon. Because you have two sides there, 1 and 2, that are collinear. That doesn't make a polygon. All right, we've discussed the rules for polygons. Mostly you just want to make sure it doesn't have curved sides. That second rule, you're not going to see that come up too often. And so the time has come for you to decide which of the figures that I have put on this slide, there's 4 of them there, are polygons. Take a moment and determine which you think are polygons. And what you should have decided here is that there are 2 figures here that are polygons, and then there are 2 figures that are not polygons. And let's talk about the ones that are not polygons real quickly. Whoops, let me go back a little bit. The ones that are not polygons are going to be, of course, the ones that have curves to them. So that oval is not a polygon. And the same with this figure that has this kind of curve right there, not a polygon. And then the other 2 figures are. You can see that this star is made up of a bunch of line segments. I won't trace them all, but it's made up of a bunch of line segments. Each line segment intersects exactly 2 other sides of the figure. All right, so that is a polygon. And here, this 4-sided figure, where all the sides are line segments, no curves to it. That's also a polygon. Should be fairly simple for you. All right, let's move on. The next thing I want to talk to you about is how you determine whether a polygon is convex or concave, because that is one way that we classify polygons, is as convex polygons and concave polygons. And since we're talking about those words convex and concave, the other place I know that you will see those particular words is in a science class when you're looking at lenses and how light shines through a lens. There are 2 common types of lenses that are used, and one of those is a convex lens. The other one is a concave lens. All right, now I'm trying to describe what convex and concave are. I'll do a little bit of the science here as well, but mostly the shape is what I'm referring to. You can kind of see in this convex lens that as light gets to the lens, it's then refocused to a central point called the focal point on the other side of the lens. Everything kind of bends toward the middle. Whereas in a concave lens, if a ray of light hits that lens, it's dispersed. Those rays don't intersect on the other side of the focal point. They're dispersed. All right. And here's the way I want you to remember which one is convex and concave. Really, I go with concave on this. With a concave lens, it really looks like 2 of the sides are caving in. It kind of looks like that is caving in. Kind of looks like that's caving in. And so that's how you can remember it's concave. With convex, it kind of looks like all the sides are poking outwards. All right, now let's relate this to polygons. And I'm going to give you some rules here, but it's going to be a pretty simple thing for you to remember, I believe. Here's an example of a convex polygon, that four-sided figure that we looked at a couple slides ago. And here's the rule for convex, and I'll explain how you apply the rule. In a convex polygon, no line containing a side of the polygon contains a point in the interior of the polygon. No line containing a side of the polygon contains a point in the interior of the polygon. Now, what in the world is a line that contains a side of the polygon? Well, if you were to extend this side of the polygon, right there is the line that contains it. And that line does not contain any points in the interior of the polygon, which is what I'm shading right now. And it doesn't matter which side you extend, because that's really what we're doing, is extending the sides. If you extend any side of this polygon, none of them intersect the interior of the figure. Alright, so that's convex. And just kind of related to what I said about the lens a moment ago, it looks like in a convex polygon that everything is kind of poking outwards. There's no sides that are caving in. Now let's compare that with a concave polygon. Turns out the star that we looked at is a concave polygon. Now let me start with the caving in part. Can you kind of see how some of the sides are pointing inwards? Okay, so it looks like it's caving in, so that's concave. Let's look at a more technical definition here. In a concave polygon, there are one or more lines containing a side of the polygon that also contain a point in the interior of the polygon. If I go back to extending sides of this polygon, you're going to notice, for instance, this one, that as I extend that side, that line that contained that particular side of the polygon is intersecting the interior. Some of the points in the interior are also part of that line. And that turns out to be the same for every line here, but it only has to be true for one line. Okay, there you go. That line extending one of the sides, it goes through the figure. All right, that means it's concave. All right, what I'd like you to do right now is pause, and I'd like you to answer this question in which you are determining whether each of these figures is a polygon. And if it is a polygon, I want you to tell whether it's convex or concave. Should be a fairly simple thing to do. I'll give you a few moments. You should have determined that the first figure is a polygon and that the third figure is a polygon. But the middle figure was not a polygon. And the reason, of course, the middle figure was not a polygon is because it did have this curved side. Not all the sides were straight or line segments, in other words. Then, as far as whether these polygons, the first and the third figures, are convex or concave, well, you can see that the first one is convex because there is a pair of sides that are kind of caving in. Or if you wanted to look at it as when I extend the side, it goes through the interior. That makes it concave. Whereas every side in this third figure, if you were to extend, none of the lines that you extend would ever possibly go through the figure, and so that makes that a convex polygon. Alright, really simple principles, but you do have to pay attention to some details. Hope that makes sense. I'll see you in the next video.